All right, here is question 2 from your little review packet. So this was kind of a different question. We did see this specific question before, but it's not something we're as comfortable with. It asks you to explain when they say a positive linear strong relationship, what do those words actually mean? So it can make you think a little bit about what those words actually are. So for positive, I put as the length of wolves goes up, the weight tends to go up as well. So that's what they said here. Wolves with higher values of length tend to have higher weights. The relationship, okay, so that's their example. And then linear relationship means as length increases by 1 meter, weight tends to change by a constant amount on average. I said the rate of change for length compared to the height is constant, or the points fall near a line. A strong relationship means the data points fall close to a line. I said the actual weights of the wolves is typically close to the predicted weight of the wolves based on the LSRL, or the residuals are small. So let's look at their requirements to get full points. You had to have a reasonable definition of positive, a reasonable definition of linear, a reasonable definition of strong, and at least one definition in context. So I have the first definition in context for sure. The length of wolves goes up, the weight tends to go up as well. So I have the context. So check for context first. Make sure at least one of your things, you talked about the weight and the length of the wolves. I actually did all 3. You should always try to include context whenever you write an explanation, because they are often looking for context. That's a big part of this class. And then here, it's really handy. They give you good examples and bad examples for each of the different relationships. So here is the examples for positive. Okay, I thought I fixed it so I could write, but it's not working. So acceptable response, as length increases, so does weight. Longer wolves weigh more. The points on the graph go up as you move from left to right. All of those are good. Bad examples, as length goes up, weight changes. So you need to indicate if weight is going up or down. Both length and weight get bigger. This is bad communication, doesn't make any sense. The correlation is greater than 0. So you can't just indicate that the correlation is positive. That's just saying what positive is. It's not explaining what a positive relationship actually is. So I had the first one. Okay, good examples for linear. The points generally follow a straight line. I actually said points fall near a line. The relationship between X and Y is straight, or length and weight have a constant slope. So that's what I talked about. The rate of change is constant. The rate of change is the slope. That the rate of change is the terminology we use, particularly in calculus. So that's good. Make sure you have one of those. The points all line up is not correct because the points aren't necessarily all in a perfect line. You can draw a straight line through the points, but we don't expect to be able to draw a straight line. It should generally follow a line, but it's not going to be, our points are not going to connect and make a perfect line unless the correlation was exactly 1. There's a positive correlation, so that has nothing to do with it being linear. For each increase in X yields a 35.02 increase in Y. That is an attempt at an interpretation of the slope, but that is not what a linear relationship. There's not a good definition for linear. For strong, acceptable responses, observed values are close to predicted values. The actual weight of the wolves is typically close to the predicted weight of the wolves. So that's the one that I used. Deviations from the least square regression line are small. deviations from the least square regression line are the residuals. So you could have worded it that way, or you can call it the residuals are small. Or the correlation coefficient is close to 1. They allowed that here. Unacceptable responses, all the points are close together. The scatter plots are clustered together. That doesn't make sense at all. There's a high positive correlation. Yeah, doesn't explain what strong means. So you should have, if you have all 4 of these checked off, you got essentially correct. If you had 3 of the 4, was partially correct. Unfortunately, if you had less than that, it was incorrect. So if you missed the context and then you missed 1 other, it was incorrect. Or if you missed 2 of these, it was incorrect. So context, remember, is very, very important. Here they gave us the LSRL and asked you to interpret the slope. Remember, slope is change in y over change in x. So a lot of times I'll write that out, change in y over change in x. So this number would represent the y. So that many over 1. I put the y units on top, the x units on bottom. Once I have that format, writing the interpretation is really easy. When the length of the wolf increases by 1 meter, so I started with x, when x increases by 1, that's what this says, the predicted, so remember this represents, or the predicted weight increases by 35.02. Also acceptable would be on average, or probably estimated again. Let's find out. So that they pretty much should have written. Okay, so they worded it in kind of a weird way. The slope of 35.02 indicates that 2 wolves that differ by 1 meter in length are predicted to differ by 35.02 kilograms in weight, with the longer wolf having the greater weight. So you could write it that way. My way should be correct. Let's find out. The correct value of 35.02 for the slope. So I got the right number. An interpretation that includes an increase of a specified amount of weight for each unit increase in length. So I indicated 1 meter increase and then a specified increase. So I'm going to put the check there. An indication the relationship is not exact by using words such as on average or predicted. So I used predicted. You could have also used on average. Try to stay away from approximate because I've seen them have issues with that word before here. I don't know why, but predicted or on average are the words that you should be using. And then part C asks you to find the weight of the wolf. So this means the actual weight, which is y. So I want to know what y is, not what y hat is, but what y is. So remember the residual is equal to y minus y hat. Y is the actual weight, y hat is the predicted weight. To find the actual weight, we're going to first have to find the predicted weight. To find the predicted weight, we plug in x, 1.4 meters, into my y hat equation from up here. And I got 32.568. So that goes in for y hat. For y, that's my unknown variable. My residual goes here. And then I solve, I get 22.898 kilograms for y. So that's my final answer. And I don't need to do anything else. And don't answer extra questions that they don't ask for. But suppose they asked you if this weight was underweight or overweight, this wolf would be underweight compared to what we predicted, because that number is 9.67 below what we expected. So this is an underweight wolf. If I was interpreting the residual, I would say the actual weight of this wolf was 9.67 kilograms below the predicted weight for this wolf. But again, don't answer questions that they didn't actually ask for. So don't answer that unless they ask you for it, because if you answer it and you say something wrong, you lose points. Part C a correct computation for the predicted value. So you needed to correctly calculate y hat, a correct computation for the actual weight using the residual and the predicted value. So if for some reason you got this number wrong, but then you set this up correctly with the number you got here, you would still get credit for the second component. Make sure you show work. This is sufficient amount of work. This should be the minimum amount that you have. You don't have to have that, but you should have this, and then your answer. So if you have both of these things, then you should be getting essentially correct. So note here, if you just set this up and you didn't actually like write down it equals 32.568, and then you maybe did this and then you did plus 0.96, or yeah, if you did this and then you just wrote minus 9.67, that's still indicating how you got all the numbers. If you just essentially did them all in one step, that would be fine. Arithmetic mistakes are overlooked. So if you set up everything correctly and you somehow got the wrong answer because you mistyped a number, then you would still get full credit. As long as they don't lead to an unreasonable answer. So if you did that and then you got a negative weight, you would only get partially correct. But if you did this and then you wrote down 0.586 instead of 0.568, you would still get essentially correct. So if you have both of those essential, one of the two is a partial. So I remember I got essential here and essential here. To get essential on to get partial on part B, you had to get 2 of the 3 components. Here you need 1 of the 2, here you need 3 of the 4. So it's harder to get the partial, but it can be harder to get the partial when there's multiple parts. And scoring is the same way. 3 E's is a 4. So this is a 4 out of 4. 2 E's and 1 P is a 3 out of 4. 2 E's and an I. An EPI or an EPP or 3 P's are 2 out of 4. 1 E and 2 I's is a 1 out of 4. 2 P's and an I is a 1 out of 4. Less than that is a 0 out of 4. So a PII or III is a 1 out of 4, is a 0 out of 4. That's the end of question 2. We will now move